nothing in the world can compare to it. It will be called the F-47. That was the declaration made by President Donald Trump at the White House on March 21, 2025, as he announced the awarding of the contract to build the U.S. Air Force's sixth-generation fighter jet. This isn't just a weapon. It's a symbol of America's ambition to maintain absolute dominance in defense technology and global strategic power in the 21st century. So, what does the F-47 bring to the table? Back in 2005, the United States held a commanding lead in fifth-generation fighter technology, thanks to advancements in stealth, maneuverability, and sensor integration. The F-22 Raptor, followed by the F-35 Lightning II, set new benchmarks for modern air combat, allowing the U.S. to maintain air superiority for nearly 2 decades. It wasn't until 2017 that China entered the arena with the Chengdu J-20, the first fifth-generation stealth fighter jet operational outside the United States. Then came 2020, when Russia officially deployed the Sukhoi Su-57, a direct challenge to American air dominance. Meanwhile, emerging players like Turkey's TFX-CAN, India's AMCA, China's J-35, and Russia's Su-75 Checkmate joined the global race. Still, none of these platforms have yet matched the F-22 or F-35 in stealth or avionics superiority. This gap has allowed the U.S. to maintain a significant lead, at least for now. However, the sixth-generation fighter race is heating up, and it's no longer a one-player game. In Europe, France, Germany, and Spain, led by Dassault Aviation and Airbus, are jointly developing the Future Combat Air System, FCAS, aiming to replace the Rafale and Eurofighter Typhoon with a next-gen air superiority platform. Meanwhile, Britain's BAE Systems and Italy's Leonardo have teamed up on the Tempest project, aiming to succeed the Eurofighter Typhoon in their respective air forces. In 2022, Tempest merged with Japan's sixth-generation fighter project, the FX, forming what is now known as the Global Combat Air Program, GCHAP. But perhaps the most eye-catching developments are coming out of China, where the nation's defense industry has seen an astonishing acceleration in recent years. This culminated on December 26, 2025, when, without any prior public disclosure, China conducted flight tests of 2 unknown aircraft, previously unseen by the international community. Based on observed design characteristics, speculation quickly spread that these were the Chengdu J-36 and Shenyang J-50, 2 sixth-generation fighters currently under development. It's clear, the sixth-gen fighter race is quietly raging, and it's fierce beneath the surface. Who will cross the finish line first remains a big unknown. As technological gaps narrow, the United States is under growing pressure to accelerate its research and development efforts in order to maintain the edge. At the forefront of this race is NGAD, the Next Generation Air Dominance Program, America's ace in the hole and its vision for future air superiority. The roots of NGAD can be traced back to 2010 to 2014, when the concept of penetrating counter-air, PCA, began to surface in U.S. strategic documents. This outlined the urgent need for a next-generation fighter with superior sensors, deep penetration, and high survivability against increasingly sophisticated anti-access area denial (A2AD) systems, particularly in the Indo-Pacific, where the U.S. faces peer-level adversaries like China and Russia. U.S. military experts also recognize the upgrade limitations of the F-22 and the F-35's design as a multi-role fighter, not a platform built purely for air dominance. As a result, in 2014, the NGAD initiative was formally launched by the Defense Advanced Research Projects Agency, DARPA, and the U.S. Air Force, marking the beginning of a new era in American air power development. The goal of NG is not merely to develop a new fighter jet, but to create an entire air dominance weapons ecosystem to replace both the F-22 Raptor and the F-35 Lightning II. The program was allocated $9 billion in funding through 2025, with the identity of its lead contractor kept under wraps. By September 2020, the U.S. Air Force announced that an NGAD prototype had already completed a successful flight test, though no images or further details were released in order to preserve operational secrecy. Between 2022 and 2023, the Pentagon revealed a substantial budget increase for NGAD, raising the total to around $20 billion, and officially designated it as a critical strategic initiative for the post-F-22 era. The Air Force also confirmed that NGAD would include a manned fighter to replace the F-22, as well as collaborative combat aircraft, CCA, advanced sensor suites, weapons, AI capabilities, and next-gen data connectivity. A major development was expected in 2024, with the Air Force set to select a primary contractor from 3 competitors: Lockheed Martin, the company behind the F-22 and F-35, Northrop Grumman, manufacturer of the stealth B-2 Spirit bomber, and Boeing, better known in recent years for its troubled 737 MAX commercial line, plagued by a string of technical scandals, ranging from minor flaws to catastrophic failures. However, in July 2024, Air Force Secretary Frank Kendall announced that the manned component of the NGAD program was being temporarily paused. The reason? The projected cost of a single 6th-generation fighter had reached $300 million per unit, twice the cost of an F-22 and triple that of an F-35, placing enormous strain on the Air Force's budget, particularly amid broader defense spending cuts. But everything changed in December 2024, when China revealed it had built 2,000 stealth aircraft, believed to be the J-36 and J-50. This bombshell reignited debate in Washington about the NGAD program, which was then in limbo. Speculation that China's Chengdu-built fighters could rival the NGAD served as a wake-up call for U.S. defense planners, breathing new life into the project. On March 21, 2025, President Donald Trump announced that Boeing had overtaken Lockheed Martin to officially become the lead contractor for the manned NGAD platform, the 6th-generation fighter designated as the F-47. As the sitting president put it, the generals picked the number. That's the name. The number 47 carries deep symbolic meaning. First, it pays tribute to the legendary P-47 Thunderbolt, one of the most iconic fighter aircraft in World War II history. Second, it commemorates the year 1947, the moment when the United States Air Force was officially established as an independent military branch. And finally, as fate would have it, Donald Trump is also the 47th President of the United States. So, what makes the F-47 revolutionary? The most critical aspect of the F-47's design lies in its future-focused combat philosophy. As previously noted, the F-47 is not a standalone aircraft. It's a command and control platform in the sky, integrated with advanced artificial intelligence to assist pilots in data processing and decision-making. Under its command are numerous collaborative combat aircraft, CCA, smart, unmanned drones equipped with sensors and weapons. Supporting this aerial force are ground command units, airborne early warning planes, satellites, and other assets, together forming a digital swarm where humans, AI, and machines work in tight coordination. At the center of it all is a tactical data-sharing system that links air, sea, and land forces in real time. For example, if any information about a target's location or status is picked up by a drone, satellite, AWACS, or ground-based radar, the F-47 pilot receives it almost instantly, allowing them to respond with precision. They can command multiple UAVs in real time or delegate specific tasks to onboard tactical AI, operating autonomously when needed. This architecture allows the F-47 combat system to deploy an infinite range of highly adaptable tactics, making it capable of adjusting dynamically to real-world combat conditions. A basic combat model for the F-47 looks like this. An unmanned aerial vehicle, UAV, flies ahead to gather data for the F-47. Then, the onboard AI quickly processes the information, identifies targets, and activates precision weapons. In another scenario, the F-47 receives target coordinates via satellite, then uses drones to bait and mislead enemy radar, creating a diversion while it strikes from another angle using GPS-guided bombs. Throughout the entire operation, UAVs and CCAs, collaborative combat aircraft, act as the eyes and ears of the F-47, entering dangerous zones to emit signals or collect data. This allows the F-47 to avoid using its own active radar, which would otherwise emit detectable signals, thus preserving its stealth profile. The result? A significantly reduced risk of the command aircraft being detected or destroyed. Initially, each central F-47 was expected to control 2 cooperative drones. This alone could outmaneuver enemies with feints and diversions that turn them around like spinning tops. But if the number of drones increases to 3 or 4, adversaries would struggle to keep up with the unpredictable, multi-vector tactics deployed by this futuristic combat system. To execute such highly dynamic strikes, the F-47 requires cutting-edge technological breakthroughs. The first thing that stands out when you look at a sixth-generation aircraft is its unconventional appearance, a design unlike any fighter jet seen before. Take the F-22 Raptor, currently one of the best stealth fighters. When compared, the sixth-gen models, including the F-47, eliminate vertical and horizontal tail surfaces. There are also fewer sharp angles in the structure. Why? Because such features increase radar cross-section. The trend in modern stealth aircraft is towards smooth, angled surfaces that deflect radar waves rather than bouncing them directly back. As you can see, China's potential sixth-gen designs, along with the F-47, follow this trend with diamond-like shapes, steep angles, and tailless bodies. Radar and electronic warfare systems are now fully embedded into the aircraft's body, avoiding the need for external antennas like those on older generations, ensuring a sleek, flat outer surface. In addition, America's most advanced fighter jet features a next-generation radar-absorbent and infrared reflective coating, which more effectively reduces heat signatures and electronic emissions compared to the F-22's stealth skin. All of this contributes to the F-47 achieving near-absolute stealth, with a radar cross-section RCS potentially even smaller than the F-22's 0.0001 square meters. However, this stealth-optimized design comes with both benefits and challenges for flight stability and maneuverability. Vertical and horizontal tail fins traditionally provide pitch and yaw stability. Without them, the F-47 becomes less stable, particularly at low speeds or during high angle of attack maneuvers, increasing the risk of losing control. To compensate, the aircraft must rely on advanced flight control systems, such as enhanced fly-by-wire technology or integrated control surfaces on the main wings. Some unofficial sources also suggest that the F-47 might use fixed canards, forward winglets, to generate additional lift and maneuvering control, offsetting the tailless design. Canards can improve lift at low speeds and maneuverability during aggressive angles of attack, while enhancing pitch control, especially during tight turns or evasive maneuvers. However, the trade-off is that canards also increase radar signature, especially from side angles or during dynamic movement. If the F-47 does in fact feature canards, it would represent a deliberate compromise between stealth and aerodynamic performance. Another top priority for the U.S. military is range. They aim for the F-47 to have a significantly greater combat radius than any current fifth-generation fighter. While the F-22 has a maximum range of approximately 3,000 kilometers with external fuel tanks, and the F-35 around 2,200 kilometers, the F-47 is reportedly designed to reach up to 4,000 kilometers without mid-air refueling. To achieve this, the F-47 must integrate a wide array of cutting-edge technologies, especially in its engine system. According to available information, the F-47 will most likely be powered by one of two next-generation engines currently in development, the XA-102 by General Electric or the XA-103 by Pratt & Whitney. Both are part of the U.S. Air Force's Adaptive Engine Transition Program, AETP, a project focused on creating adaptive cycle engines that can seamlessly switch between operating modes, allowing aircraft to fly farther, longer, and with greater fuel efficiency. As a result, the F-47 is expected to reach maximum speeds of up to Mach 2, about 2,470 km per hour, and sustain supersonic flight without engaging afterburners, a capability the F-22 does not possess. This also significantly reduces the aircraft's infrared signature. Additionally, the S-shaped air intake ducts help conceal the engine fan blades, which are typically major radar reflectors. Every design detail of the F-47 serves one overarching purpose: enhancing overall stealth capability for this next-generation war machine. Yet the most revolutionary feature lies not in its structure, but in its internal electronics, the very core that will redefine the future of aerial warfare. As a sixth-generation fighter, the F-47 represents a quantum leap in military aviation technology. It's not merely a combat aircraft, it is engineered to be a central battlefield coordinator, where artificial intelligence, multispectral sensing, advanced radar systems, and networked combat architecture come together as a unified system. Far beyond the limits of fifth-generation fighters like the F-22 Raptor or F-35 Lightning II. AI is deeply integrated into every facet of its operations. Not only does it serve as a virtual co-pilot, but it also possesses the ability to learn, analyze real-time battlefield data, make tactical recommendations, and even autonomously prioritize targets or initiate threat avoidance responses. As previously mentioned, the AI onboard the F-47 has also been developed to coordinate and command groups of supporting unmanned aerial vehicles, UAVs, a capability that forms a core element of future air combat doctrine. In modern combat scenarios, the F-47's AI enables it to carry out complex missions, such as dividing strike forces, conducting reconnaissance, executing electronic warfare, and deploying kamikaze-style drone attacks. All of this is intelligently and autonomously orchestrated from the cockpit of the manned mothership. In addition, the F-47's radar system is considered one of the most revolutionary advancements in long-range sensing and anti-stealth capabilities. Unlike the F-22 and F-35, which rely primarily on X-band ESA radars, the F-47 is equipped with a next-generation radar capable of multi-band operation. This drastically improves its ability to detect stealth targets, which are typically optimized to evade conventional radar frequencies. By leveraging advanced AI algorithms, the F-47 can analyze radar emission patterns, predict adversary intent, and execute adaptive jamming strategies, a level of sophistication that previous generations could not achieve. Another standout feature is its ability to track multiple targets simultaneously while delivering ultra-fast data processing to the pilot. Complementing this is a multispectral sensor suite that fuses data from a wide range of sources: infrared, optical, electromagnetic signals, electronic emissions, and radar returns. Unlike older systems where sensor data remained fragmented, the F-47 integrates information from all independent sensors into a unified 360-degree battlefield awareness picture, visually enhanced through an AI-assisted interface. This not only gives the pilot earlier and broader situational awareness, but also allows for faster and more precise reactions to rapidly evolving threats. The F-47 is also a critical node in the broader integrated combat network, a battlespace environment where everything from satellites, ground stations, warships, UAVs, and other manned aircraft are seamlessly interconnected. This aircraft node not only receives battlefield data, but also distributes real-time intelligence to other units, serving as the central nervous system in a multi-domain joint operation across air, sea, and land forces. It operates as a decentralized combat environment hub, a critical feature for maintaining force flexibility and operational continuity under contested conditions. To fulfill this role, military data link systems are the backbone of connectivity. Currently, the F-16 data link, known widely as Link 16, is the most viable and widely adopted solution. It is used by NATO and allied forces to transmit real-time tactical information across air, sea, and ground platforms. With a data transfer rate of approximately 238 kbps and extremely low latency, Link 16 enables the sharing of radar sweeps, target coordinates, and mission commands in real time. Moreover, its signals are encrypted and equipped with frequency hopping capabilities to prevent jamming and interception, ensuring secure communications. Thus, Link 16 acts as a foundational bridge allowing the F-47 to seamlessly integrate with combined forces. However, when it comes to communications between stealth aircraft, the U.S. has developed a dedicated channel called the Multifunction Advanced Data Link, MADL. Compared to Link 16, MADL offers enhanced encryption, low probability of intercept, and anti-jamming measures, allowing stealth aircraft like the F-47 to communicate covertly without exposing their positions to enemy radar or sensors. This gives the F-47 a multi-layered communication architecture, one that is both broad in reach and deeply secure, tailored to both open and stealth scenarios. In terms of electronic warfare capabilities, the F-47 is equipped with next-gen jamming and deception systems. Its self-protection suite has been significantly upgraded with technologies like radar warning receivers, RWR, to detect potentially hostile radar emissions, directional infrared countermeasures, DIR-CM, to locate and neutralize heat-seeking missiles, and digital radio frequency memory, DRFM, decoys to spoof radar-guided threats. What's more, the F-47 is capable of targeted jamming, intelligently analyzing enemy radar signatures, and crafting a customized electronic response, which enhances its survivability in highly contested environments, where electronic warfare is now the norm, not the exception. Finally, drawing lessons from the F-22 program, all systems on board the F-47 are designed with a modular open architecture approach. Both hardware and software are split into interchangeable blocks, using standardized interfaces to ensure compatibility with contractors and vendors from different countries and organizations. While open in structure, the system maintains independent security layers between modules, ensuring that interoperability does not come at the cost of vulnerability. It's cooperative, but not exploitable. This modular architecture allows for faster upgrades, enabling even complex enhancements to be implemented more efficiently, while extending the operational lifespan and ensuring system security over time. Most importantly, it's non-restrictive. The design intentionally leaves room for growth and scalability, allowing future capabilities to be integrated seamlessly without overhauling the entire system. It ensures aircraft maintenance and preserves battlefield superiority throughout its lifecycle, without requiring complete platform replacement. At a glance, in light of rapid technological shifts and the evolving demands of future warfare, this becomes a strategic design feature, a foundation upon which the entire Hawklet 09 Modern Force architecture can expand. From an industrial perspective, the F-47 also promises a tech innovation ripple effect, catalyzing advancements across a range of supporting industries, including artificial intelligence, ultra-lightweight materials, aerospace electronics, and autonomous navigation systems. The F-47's development may become a centerpiece for international collaboration, as many allied nations seek to join the supply chain or customize the platform to fit their own defense needs. Moreover, with its open software ecosystem and adaptive sensor framework, the F-47 can remain competitive for decades without the need to redesign the airframe itself. A particularly critical factor as modern defense budgets demand long-term return on investment. In today's era, air superiority is no longer defined solely by speed, stealth, firepower, or maneuverability. It is increasingly decided by a platform's ability to process information, execute multi-domain missions, and adapt in real time to a constantly shifting battle space. In this new reality, the F-47 emerges as a brilliant symbol of the next generation of air power. But as the arms race between great powers accelerates, will it maintain its edge in the decades to come, or is it merely a transitional milestone on the path to an even more dominant future platform? Only time will tell.